L'Hopital's. I know when to do L'Hopital's, I need to get it written as a rational function. Currently, I have this exponential function because I have x as the exponent. So just like we did on the last one, we're going to set y equal to the limit, and then we're going to do the ln of both sides. That's kind of the only strategy we have to get that exponent, that x, out front of the everything else. So if I do ln of both sides, that will give me ln of y equals, you can put the ln kind of inside, so the limit as x goes to infinity from the right, remember that plus means from the right, of x ln sine x. Okay, so that ln is a strategy which we kind of already know because we've used it before to get that x out of your exponent. And the ln can kind of go inside the limit. Okay, we haven't done the L'Hopital's rule. We haven't done anything with taking the derivative of the top and bottom because I have to write it as a fraction. So kind of using the same strategy we did on the last one, how could I write this as a fraction? We'll worry about the left side at the end, hopefully if I remember. What can I use? What strategy can I use to write this as a fraction? Just the same strategy we used on the previous one. Yep, multiplying by x is the same as dividing by 1 over x. So that's kind of a quick strategy. You may not think of that. It makes sense. You know, dividing by 1 over x is the same as multiplying by x. And that kind of gets you your fraction, so we can do L'Hopital's rule. So let's do L'Hopital's. Now I can actually take the derivative of the top and bottom. So derivative of ln of sine x, so it's going to be 1 over sine, because the ln is 1 over, keep sine the same, times derivative of sine cosine x. All over, we already kind of talked about it. The derivative of 1 over x is, so negative x to the negative second, which is the same as negative 1 over x squared, just like we did the previous one. So it's negative x to the negative second, but then you can move that to the denominator. Let's see where that gets me. Let's simplify a little bit. So that will get me the limit as x goes to 0 from the right. The top will simplify to what? Another thing that you should be able to recognize for the final, which is cosine over sine is cotangent. I wouldn't think you'd need to know all the like trig identities, like double angle, like none of the like kind of weirder ones, but like the basic sine over cosine is tan, cosine over sine is cotangent, 1 over secant, or 1 over cosine is secant, stuff like that. Over this. Let's try to rewrite this. How can I rewrite this so it doesn't look as crappy? Because I already did L'Hopital's. Well, we might have to do it again, so we want to keep it as a fraction. Is there anything? Yeah, I can kind of rewrite this a little bit. Cotangent is the same as what? Don't say cosine over sine, because that would get me back to what it just was. But cosine is the same as 1 over cotangent is the same as 1 over tangent, because they're flipped. So that means I can make cotangent 1 over tangent. So I would put tangent x in the bottom, because that's the same as 1 over tangent. And then negative 1 over x squared is the same as multiplying the top by what? Yeah. So I just kind of manipulated it a little bit so that when if I had to do the L'Hopital's rule again, I could easier. So cotangent is 1 over tangent, so that moves tangent at the bottom. Negative 1 over x squared. When I take the derivative of this, or not the derivative, dividing by 1 over x squared is the same as multiplying by x squared, so that's the negative x squared on top. Now let's try to plug in 0 and see if that will get me anything. If I plug in 0, that will give me what on top? 0. Tangent of 0, y over x. Tangent is y over x, so it's going to be 0 over 1. 0. 0 over 0, L'Hopital's. So this is the case where I got it simplified. I tried L'Hopital's. I still got 0 over 0. I still got an indeterminate form. So we're going to, but it's written as a nice fraction. So we can go ahead and take the derivative of the top and the bottom, which isn't that bad. So we kind of simplified it down nicely so that taking the derivative wasn't awful to do. Derivative of negative x squared. Derivative of tangent. Secant squared x. However you want to write it. Let's try to plug 0 in again. On top will get me 0. Now secant squared, we don't know secant on the unit circle. Secant squared is the same as 1 over cosine, square the whole thing. So we can rewrite secant squared as 1 over cosine and then square the whole thing. That makes it easier to think about using the unit circle. Cosine of 0 is 1. 1 over 1 is 1. 1 squared is 1. So I actually get 1 in the denominator, so my answer is actually 0. However, that is just the right side. So I have to take ln of y equal to 0. So you have to take the left side, the ln of y part, set equal to 0. And then we can kind of think about this. Think about the graph, if you want to, of ln. Ln of what value gives you 0? So if you think about ln is like this. So when y is 0, x is 1. So y is 1. Okay, we're going to look at one more. This is taking longer than I expected, but that's okay. IU cares more about L'Hopital's than I detected, so we still have plenty of time. It's not like we have a week left before the final. Okay, let's look at example 7, and then we'll be done. Okay, so example 7, let's plug in 1. So you always plug in with limits, always plug in. If it gets you an indeterminate, then you can try to do L'Hopital's. So if I plug in 1, let's see what I get. So if I plug in 1, this will give me 1 over ln of 1. You can use the graph down here we just did. Ln of 1 is 0. And let's see, minus 1 over 1 from the right, so it's going to be 1 minus 1. So it also gets you 0. So we're kind of here, we're not really sure. 1 over 0 is in an indeterminate form. However, we need to kind of look at this. We have to kind of think about this. So as I look at this, as x is approaching 1 from the right. So as x is approaching 1 from the right as my graph, my ln graph. So my values aren't actually going to be 0. My values for my ln of x part here, as I approach 1 from the right, my denominator, the ln of x, is getting what? Smaller. Okay? So if I have, so they're not actually going to 0, they're approaching 0. So if I have constant over smaller and smaller numbers, the whole thing is going to infinity. So it's actually infinity minus. Now let's look at my second fraction. If I plug in 1, I'm approaching 1 from the right, which means my x are going like 4, 5, and then 4, 3, 2, getting closer to 1. So what's happening to my fourth? If I plug in
4, I get 3. It's approaching 0. It's getting smaller. So if my denominator is getting smaller, 1 over smaller and smaller and smaller numbers, infinity. Okay, so that one's kind of a weird one to think about. Just plugging in 0 didn't really get you to an indeterminate form. But if you think about, I'm approaching 1 from the right. I'm not actually equal to 1, which is what limits mean. Okay, so infinity minus infinity, that's an indeterminate form, so we can do L'Hopital's. So I would say if you are working on limits and you can't like simplify or multiply by the conjugate or whatever, and you notice that like it's weird, I would kind of think, okay, is this L'Hopital? Like kind of use that. Okay, in order to do L'Hopital's, first thing we're going to worry about, well, first of all, I don't have any variables as the exponent, so I don't have to do ln like I just did. We're going to simplify, and we're going to try to get this into just a fraction over a fraction. So if I look here, at my original, what can I do to get it just to be a fraction, like a single fraction? Yeah, we can combine these two like you've done before. So if I combine these two with common denominators, the limit as x goes to 1 from the right, that will be, my denominator will be ln of, I'll just do it like this, x minus 1 times ln of x. So we've combined two fractions together. So your denominator is going to be x minus 1 times ln of x. Fraction on the left, I have to multiply top and bottom by x minus 1. Fraction on the right, I'd have to multiply by ln of x. Now I have a fraction. Let's try to plug in 1 and see if it gets me anywhere. Okay, if I plug in 1, that will get me 1 minus ln of 1 over 1 minus 1 times ln of 1. Let's see what that gets me. So once you get into a fraction, well, just kidding. Well, did I have it? Just a second. I haven't taken the derivative yet. Let me take the derivative before I plug it in. Sorry, I jumped the gun. Before I plug it in, take the derivative. That's what L'Hopital's mean. Get it a fraction, take the derivative of the top, take the derivative of the bottom. See where you get. So if I take the derivative of the top, I'm going to have derivative of x, 1. The minus 1 we cancel. Derivative of negative ln of x. 1 over x. On the bottom, I'm going to have to do product rule. Okay, so first, x minus 1 times the derivative of ln of x. Okay, so first times the derivative of the second plus the second ln of x times the derivative of the first, which is 1. Okay, let's simplify a little bit. Let's see what we can do to simplify. On the top, let's make it one fraction on the top. On the top, if I combine it into one fraction,
My denominator will be x. It's going to be x minus 1. Is that right? So I'd have to multiply this 1 by x, so you get x minus 1 over x. That's the top. And we can actually do the same thing to the bottom. As I look at the bottom, my only denominator will be, so actually, if I write this as this, this would be x minus 1. You can rewrite it like this. So it's a little easier to see, because that x minus 1 times 1 over x is just x minus 1 over x. So if I get a common denominator of x here too, this would be x minus 1. I'd have to multiply this one by so the left fraction is done because it's already over x. The right fraction, I'd have to multiply top and bottom by x. So plus x ln of x. So just kind of working through, kind of using algebra to work through. Something nice that will happen here. Yeah, denominator. Both your denominators and top and bottom are x, so those cancel. So I have the limit as x approaches 1 from the right of x minus 1 over x minus 1 plus x ln of x. You cannot cancel out the x minus 1s because I'm adding it on the bottom. Now it's pretty simplified, so let's see where it gets me. We did L'Hopital's, we took the derivative, we simplified it down. Now let's try to plug in 1 and see if where it gets me. See if it actually gets me an answer. So if I plug in 1, I get 1 minus 1 over 1 minus 1 plus 1 times ln of 1. Top, 0. Bottom, 1 minus 1 is 0. Ln of 1, 0. So you get 0 over 0, so you're going to have to do L'Hopital. So doing all that work got me to another indeterminate form. And so now we can do L'Hopital's again and see if it gets me anywhere. So if I do L'Hopital's again, derivative of the top, 1. Derivative of the bottom, derivative of x is 1. Derivative of negative 1 is nothing. Here, yes, again, easy product rule, not bad product rule. First, times the derivative of ln of x, which is, yeah, and those will cancel in a second. So first times the derivative of ln of x plus ln of x times the derivative of the first, which is just 1. So again, there's lots. This one's a complicated one, but I want us to at least have seen this in case something like this shows up. So let's see where it not equals. Let's see where that gets me. 1 over 1 plus x times 1 over x is 1 plus ln of x. So 1 over 2 plus ln of x. So it's simplified a lot nicer after doing the derivative again, L'Hopital's again. Now let's try to plug in 1. If I plug in 1 for x, ln of 1, so that's 1/2. Now we didn't do the ln because it wasn't an exponential function, so 1/2 is just your answer. Okay. So homework, let me look at that. I'm going to give